All right, hello once again, Jeff Scott of Rankin Technical College, and as part of the Rankin Technical College Application and Website Development, or AWD 1100 Programming Fundamentals with C# class, I've been doing a series of video presentations based on the PowerPoint slides for our textbook for the class, Muroc C# 7th edition. So far I have done all of chapters 1 through 3, all of chapters 4 through 11, and chapter 12. I have made the decision, whether it's a good decision or a bad one, I guess will remain to be seen, but I'm not going to go over chapter 13, how to work with indexers, delegates, events, and operators, and I'm not going to go over chapter 15, how to work with interfaces and generics. Shouldn't say that. 15 I'll go over, but very quickly. So I'm going to, in this section then, in my humble opinion, you are responsible for 12, for 14, and that's probably going to be it, but we'll see. So I'm going to skip 13 totally. If you want to go through that, you can. Do I understand indexers? Somewhat, but I'm not going to go through them any more than that. For chapter 15 on working with interfaces and generics, again, very complex topic, all right? But I want to talk to you about an interface, okay? Now, like a lot of other programming languages, such as Java, C# only allows you to inherit from one class. It only allows single inheritance. You can only inherit from one class, but you can implement as many interfaces as you want to or need to do. Here are some of the common ones that you can use. You can also develop your own. All right. And when you do that, it's public interface instead of class, just so you know that. And you put in whatever you need to put in. So here's an example of an interface. All right, I just wanted to go over what interfaces were. I'm not going to do any more on this. So I'm going to just skip that chapter also. And again, I guess I'll have to talk to Mr. Gudmiston about this. And if he doesn't like what I'm doing, then I'm going to have to change it around a bit. But that means that we're going to cover 12, 14, and 16 in this section. I'm going to jump into 16 first, which is how to organize, document, and test your classes. So I'm going to go through that one, then go back over and do chapter 14, just because I can. All right. So chapter 16 is on how to organize, document, and test your classes. You'll notice they talk about adding XML documentation to your classes, creating a class library, using unit testing to test classes and class libraries. Those are our applied objectives. And for our knowledge objectives, describe 2 ways that you can code 2 or more classes in a single file. Describe benefits of creating and using a library. Describe the use of namespaces, partial classes, advantages of unit testing, and the AAA pattern used with unit testing. Okay? So, as they say here, this is a file with 2 classes coded one right after the other. Now you can, repeat, you can, C-A-N, do this in C#. You cannot do it like this in Java, for example. In Java, you can have only one public class in a file, but you can take another class and literally put it inside of a class as long as it's not public. All right, so here that this is more what I was talking about, that you can do something like this in Java, but I don't believe that the inner class can be public. I could be wrong. I think it has to be private. But here we've got a public class within a public class. And what are the advantages to doing that? I don't care what the book says. I think there are more disadvantages. I think it makes your code harder to read. So I would recommend not doing that. But again, people are going to do what they're going to do. Once you hear you can do something, It doesn't matter if it's what you should do or it's what you shouldn't do. All right. Here's a class that's gotten so big that they've split it into two different files. So each one of these is a partial class put together, makes up the entire class. All right, so what about namespaces? Well, I do want to mention something, and I think I showed this before, but I want to show it again. So let me bring up it's the calculator we just did. So let me bring up, let's see. Good. All right. So grab these, and I'm going to put them again inside of here, where I've got my in-class programs. All right, so let's see. What I wanted to show you virtually everything that you create inside of your project is inside of that project's namespace. Can you have other namespaces? The answer is yes. You can even have, as it shows here, a namespace within a namespace, also known as nested namespaces. All right, so you can do it like this, or you can do it like this. Now, when you add additional namespaces, you have to add additional using statements. All right, one basically for each namespace that you add. Okay, when you begin, this is XML documentation, and it used to be that you could come in here, and this is the example that they did, and again, so it used to be that you could come in here and you could put in 3 slashes, slash, slash, slash. It would turn gray. All right, and I think this is gray, and that would become an XML comment. What's an XML comment? It's additional documentation that you can add to your program. All right, here's the kind of thing that you might want to add in there. Things like, maybe like a function prologue, parameters that are required for the function, etc. So the main elements that you would use would be these. The first one, as you can see, the summary, as it says, it'll provide a general description of whatever it is you assigned it to, be it a class, a property, a method, or something else. The second comment would be a value that, as it says, describes the value of a property, or maybe if you had, for example, gender, you might have 0 and 1, 0 for female, 1 for male, or 1, 2, however you would do it. Returns, as it says, to describe the return value, and params for the parameters. What they say is when you add some of this stuff, rather, you'll be able to use the IntelliSense, and it'll pick up some of the stuff that's in there. Okay. All right. So here they've got two different projects that are both using the same class. One of the big advantages of object-oriented programming is code reuse. And I have yet to meet an IT manager that when you talk to them about reuse, their eyes don't light up a little bit. Because reuse means that you can use the same code over and over and over again. All right. And you get all the benefits. You only have to write it once. And really, every time you use it, you're in essence testing it again. So you'll notice that here's a project that, again, that has that library in it, that validator validation class. All right. And again, two different projects can access it. Now, in order to do that, all right, you very well might have to go in and add another using statement, or you're going to have to go in and right mouse click on the name of the project and go in and choose references. And then in your reference manager, you can go in and add this. Again, it may sound right now like I'm not going over this in much detail. And to be honest with you, I'm not. But when we talk about it in the actual classroom, I will go over it in more detail than we're going over it right here. There's an example of a using directive when you add your own class. And the thing that's in here, that it ends with unit testing. So the idea is, if you write a fairly complex application that has several classes, you want to make sure that not only do the classes work, but that they also work in tandem. So as it says with the unit testing process, you code test methods to call other methods of other classes. All right, so one class's methods, typically public, should be able to call another class's methods public. Then you execute test methods to verify that the code works correctly. So yeah, that's one thing to be able to call them. It's another thing after you've called them to verify that indeed everything works. And if you've got problems, as it says, you debug and fix and test again. So when you've got an app that has a lot of different components to it, all right, you basically are breaking them up into units, and you want to be able to test each unit. As it says here, unit testing helps you find problems earlier in the development cycle. It's cheaper to fix it. The sooner you find a problem in the development cycle, the sooner you can fix it, and you don't let it propagate and maybe come up and have other errors or cause other errors. You can run unit tests for a class each time you change it to detect any problems you may have introduced. You can develop and test an application more quickly because you don't have to run the application and retest it every time. Rather, you can use unit tests to just test the code that was changed. Finally, it makes debugging easier because when a test fails, you pretty much know right where it is. All right, so they talk about that a little bit in here for unit testing. That's all I'm going to cover right now. I know that was very, very, very small, but I'm going to come back and I'm going to go over Chapter 14, how to work with inheritance. And once I get done with that, I have finished what I'm covering in this section, which is just 12, 14, and 16. All right, so the next time after I get done with 14 is I'll come back and do these two chapters. All right, hopefully that all made sense, and I will see you shortly.